Hello and welcome to my new video. In this video, I'll be talking about Kmean clustering. It's a very powerful tool in machine learning, especially for the non-supervised machine learning. So we are basically giving our computer unlabeled data and telling it to divide our data into groups, separate into groups for us. So let's go ahead and look into the details for the video. So this video contains three main parts. So the first part will be the working principle of Kmean clustering. I'll be explaining to you how this module works. And next, I'll show you an example in Python using Jupyter. And finally, I will try to show you how to choose the best number of clusters in case you're not sure of how many clusters are in your data. So let's go ahead and look at the working principle of Kmean clustering. So let's say we have this kind of data. It's clear that it's divided into three main parts, and the objective is to group this data into this part. So for this two-dimensional data, it's very easy to look at the data simply and tell that this belongs to this and this belongs to that. But now imagine a situation where you have more than 2 or 3 dimensions. So that's where this tool comes in, and it's very powerful. Since we know that the data contains three main groups, we begin by the initialization process, which involves just positioning these three centroids in our dataset. Then after that, we assign each data point to the centroid that's closest to it, as you can see in this image. Then we group this data, and we basically just move the centroid to the center of each group that we've created. Then we repeat the same process. We reassign each data point to the centroid that is closest to it, and we repeat the same process until when the system reaches equilibrium. That's when it converges, and these centroids are no longer moving from one place to another. Reached an equilibrium. Okay, so one may say, what if we get a wrong equilibrium? What if our centroids converge at a wrong place? So the solution to this is very simple. We initialize the data in several ways. Let's say in this group, we can see the initialization started from here, here, here. Then we change the initialization, we change the initialization again, and we shall simply just run the code. We do the steps, and we shall get the answers, like the equilibrium for each group. And when we reach the equilibrium, we calculate the distance, the sum of the distances of the data points from the centroid. We shall choose the group that has the smallest distance from the centroid. So this is basically calculating the variance of each data point from the centroid, summing it up, then summing it up for the whole group, and giving the sum. So let's go ahead and do some clustering using Kmean. So we shall begin by importing the libraries that we need to the data, and also to plot the data and to do the separation. So from scikit-learn, we're going to import the data as blobs. Then we're going to show this data using matplotlib, and we're going to use Kmean from scikit-learn cluster to group our data into the different clusters that exist. So let's begin by creating the data that we're going to use. So our data is going to have two centers, that's 1, 1 and 5, 5. So it's in form of a 2-dimension with x and y. So we shall have one cluster center which will be centered at 1, and the other cluster center will be centered at 5, 5. Okay, so let's go ahead and make the blobs using this formula. So we declared the number of samples, which is 200. So the centers will be 1 and 2, and then the standard deviation will be 1. Let's go ahead and display this, see what So this is how our data looks like. So you can see we have like one center at 1 1. So this is one cluster, and this is the other cluster which is at maybe 1 5. So you can go ahead and play with the standard deviation. And let's say if the standard deviation was 2, what would it look like? Hard to tell. We can't really know which is the cluster, which cluster is which. Let's try 0.5. So 0.5 is actually much better. You can clearly see that we have two clusters. Alright, but let's go with 1. So now we shall go into applying the model, Kmean model. So we create the model by simply saying model is equal to Kmean. So in Kmean you have to specify the number of clusters. So here we clearly have 2 clusters. Then you have to feed the model into your dataset, which is this data that we have over here. And then to get the prediction, it's as simple as saying model.predict. Now let's go ahead and run this and see if the code runs. Okay, so let's maybe just have a look at the predictions and see how they look like. Predictions. Okay, so predictions it's just a group of zeros and ones. Let's just copy this. And then for the colors, we're just going to say color is equal to predictions. And we should be able to see the different groups. Okay, looks good to me. So the model managed to separate the data into 2 groups that we can clearly see. So here you can see that there are 2 groups, but I'm not sure which parts, which data falls in which group. And here we can clearly see by just using Kmean. So you just have to declare the number of clusters. So say the number of clusters is equal to 2. And you fit the model into X, you run the model, and you have your data separated into groups. So there are a few things we can try to look at. Let's try to look at maybe the center rate. So now let's go ahead and display the cluster centers. So it's also like very easy. Remember the clusters were 1 1 and 5 5. So to display the clusters, you just have to use model.cluster centers. So this is the code for showing the cluster centers. Then the rest is just displaying the data. So this is displaying exactly what we just saw above. Then we do cluster.plot the centroids using this code. It's just going to display the centroid. Okay, so we can see the centers. They fall at 5 5 and 1 1. Exactly what we entered. We can also try to simply like show them like what are like the centers for data, and it's an array of 4.8, which is approximately 5, and then the other one is 1.08, which is also approximately 1. Alright, so the other thing we can look at is the inertia, which is also the score for the model. So the inertia is simply the sum of the distances of each point from the cluster center. So it will be the sum of all these points, the distances from the cluster center, and also the sum of all these yellow points from their cluster center. Okay, let's go ahead and look at the code for this. So to show the inertia, it's as simple as saying model.inertia, and you can see the inertia. So here it's 416, which is okay, which is a bit big. So the score is just the opposite of this. So it's the negative of inertia in this model Kmean. And see the score by writing this code. model.score. And okay, so we can't see the score because we didn't specify x. Alright, so that's it. So the score is negative 116. We can maybe try to change the standard deviation, like make the points more distinct and see if the score improves or it doesn't. So let's say when we are creating the data, we say the standard deviation was 1. Let's try 0.5 and see. So the groups are more distinct. You can clearly see that there are two groups. And we can apply the model to the data set. The predictions, which is clearly the same, and we can now try to look at the centers, which we won't move that much. Maybe they are more accurate than before. And let's look at the score. So now the score is reduced from 416 to 91. So that means the more precise the model is, the less the score is. So the nearer the points are to the cluster center, the smaller the score. So the smaller the score, the better the model. Yep. Alright. Now, it can happen that you actually don't know the number of clusters in your dataset. Let's say from the beginning where we had a standard deviation of 2, maybe standard deviation of 2. Okay, let's try with a standard deviation of 2. So maybe here you can't tell the data is disorganized. You don't know how many clusters you have. Maybe you have 1, maybe you have 2. You are not sure. So how can you choose the best number of clusters? So this can be done using the elbow method that I already explained. So I will just show you how it works, how to do it with code. And okay, let's go back with a standard deviation of 0.5, 0.1 maybe. Okay, I'll go through the code. So I created an empty list, Inertia, and I'm going to run this for loop. And each time I'm going to get this model, and the number of clusters is going to be equal to k. So which is in a range of 1 to 10. And each time I'm going to save the inertia, which is the score of the model or the sum of the standard deviations, and I'm going to display that on the graph. Okay, so and here we can clearly see that the best number of clusters is around 2, because we saw that the score really improved from 1 to I think around maybe 400 something. Then it started reducing, but it's reducing very slowly. So this might be the optimum place. So the perfect number of clusters is 2. So that's how you choose the best number of clusters. So the other way of clustering is using mean clustering, which is basically based on the same principle. Just like Kmean clustering. The only difference here is you don't have to define the number of clusters. So it works in the same way. It will begin by initializing. It will press clusters followed by the data, and then it will try to maximize or optimize the positions of these clusters, just like Kmean cluster. So I'll go ahead and show you how it actually works. So this model works in the same way. You don't have to specify the number of clusters. You just have to say model is equal to Meanshift, then predictions is equal to model.fit predict x. We can go ahead and look at the I don't know, maybe cluster centers, see how they look like. So from here we can tell that the model created 2 clusters, one which is at around 1.1 and another one which is at 4.8 and 5.1, which is 5.5, especially exactly what we specified right before. Let's go ahead and display the results. So we are actually repeating the same thing what what has changed here is that predictions will be equal to these predictions here. And okay, now let's go ahead and display. And this is no longer Kmean but Meanshift. Alright, and it gives exactly the same thing. And here we didn't really have to initialize the number of clusters, and that's the magic with Meanshift clustering. Personally, I would go for this method because most of the times you don't know how many clusters you have, and this really gives you like solves the whole issue because it will do the initialization itself and it will optimize itself and give you the perfect answer. Alright, so that's it for clustering, Kmean clustering and Meanshift clustering.